Welcome everyone to a new video tutorial for you guys. Or would like to show you how to georeference maps in Google Earth. So let's say you have been to your library, chosen to scan a map, and you would like to make a georeferenced file out of it, a georeference TIFF or a geotiff out of it. So I will present you now with a map from my library. It is a Berlin city map, scale of 1 meter, so 1 to 10,000, and there is a georeference, or there are geo-coordinates available for that. So the UTM coordinates are printed in that map. And first of all, you should keep in mind that your project has no actual coordinate system. So first of all, decide which coordinate system your target or your georeferenced map should have. So press on Layers, Properties, and say your system is now predefined. In my case, it's a UTM coordinate system, which is a projected coordinate system. We'll go to UTM. The ellipsoid is WGS 1984, and we are located on the northern hemisphere. Be sure to use the correct zone. So most of my students have chosen the complex UTM zone because it was the first fitting value they have seen here in that list, but there are the more common UTM zones beneath it. So in my case, it's the UTM zone 33 north, and I will use that one and say okay. This has changed now, but nevertheless the spatial reference is undefined for our map, so that's fine for the moment. First of all, you see the map or the TIFF file is rotated. So go on georeferencing, flip or rotate left in my case. So now rotation is fine. I will go and zoom out, and yeah, as it was mentioned in the description of the map, the bluish coordinates will represent the UTM coordinates. So I will use them for today. So let's start maybe with the upper lower section here. Just zoom in, and there's the cross between the easting of 388 kilometers and the northing of 5,823 kilometers. So I will add a control point on this crossing of that both coordinates. So we'll go into detail. There are the pixels. I will choose the center of both pixels and just double click it somewhere. So it doesn't depend where you click it in the first case, because we will frickle around with numbers and not with the image representation of the pixel here. What I will do now, I will zoom out to the previous extent to get the information of the coordinates, and then go to View Link Table, which represent you the ground control points you have chosen and the source and reference coordinates. So the X coordinate was 388, which is represented by this number, which means 388 kilometers. So it's map unit is meters, so it's 388,000. And the Y map is, oh, what has happened here? We have missed the auto adjust button. If you make any changes in that link table and you have not chosen to unselect the auto adjust, the changing you have done here will be automatically represented in your working area. So we will just we will go to zoom to layer, and now the auto adjust button is gone. We need to zoom in one more time. So it's 5,823 kilometers north of the equator. So there we are. Let's stay with that at the moment. Go back. Maybe you can also say auto adjust. So we'll go to the full extent. Now we have the upper left corner. We will go further by using the lower right corner. So it's 580 or 5819 and 393. So we'll go to the table. You cannot add here a point, so you will need this one. Go to the crossing of that bluish lines. Now we will zoom a little bit further. Oh no, that was wrong. So we'll just delete that old point. Oh, where are we? Oh, there we are. So it has rotated automatically. That was my fault. Sorry for that. Go back to the old point. Say press OK. Just remove the auto adjust. Go back to the last extent where we have seen the values. So it was 393,000 meters and 5,800, I think 5,819 kilometers. Now you also can choose auto adjust one more time. Go to the full extent. So these are 2 points. Now we will go on. Upper right one maybe now in the moment. Now come on. So there we are. One more point. As you see, the coordinates are fitting quite well at the moment. You just need some rearranging. Okay, and now we will just add other points, and so it takes some time. You have to be in, or you shouldn't be in a hurry by doing that, because you need the quality, you need a good representation, and you have to be very careful in choosing your coordinates. So we'll just create that in a moment, and see you in some seconds. So I hope you have done it for yourself. Now I have here about, I think, 6 or 7 points created in my map, and as you can see here in my linked table, each crossing of that UTM scheme is represented by good reference coordinates, but I still have a very little RMSE error or RMSE, which isn't the kind of a problem in this case. So I also can choose second order polynomial, which will reduce the RMS error once more, but I think I will stick with the first order polynomial. You just press OK. Now you have created the reference set. What I'm doing now is I will go to georeferencing, say rectify, because I would like to calculate the new cell sizes. I will go with a cell size of 1 meter, and I would say that I would like to use bilinear interpolation. If you're not sure about the differences, you can address my other video by georeferencing. You can also go to the help file, but in my case I'm not interested in keeping the values of the colors. I'm just interested in a good representation of my map in the new file, so I'll stick with the bilinear, or maybe also cubic convolution. I'm not sure about. Let's stick with bilinear interpolation, and I will give it another file name at UTM WGS 33 manual, and I'll say save. This will take some time. So after the calculation of the old file has ended, you can start with a new project and try to find out which was the better representation or the better georeferenciation of your scene. So we will start with the new project, blank map, yeah, no. And what I will do now is I will add the manually done scene. So as you can see in the lower right corner, each pixel has a good georeferenciation. And what we will do now is we will no, that was wrong. We will add now already georeference scene, which is a Landsat scene. Click on that. So it should be beneath the smaller scene. We'll go into detail and see how is the representation by just adjusting the transparency of the upper layer, which is our map. So as you can see, there's a little shift between these both images, and we'll now add the image to image georeferenced image, which is this one here. Say add. Now you can see that there is a little shift between these both images. What can be the cause of that image is that the Berlin part in the Landsat image is on the edge of the whole scene, which results in a little shift of the total Landsat scene, I think. But still, it can be any other problem. To make a good georeferenciation, I would suggest you to stay on the GCP in the field and track the coordinates by using a GPS signal, so you can be sure where is the point you are standing at, and identifying this point on your map. So we have now created this this new map, this new georeference map. I hope you have enjoyed it. Keep that in mind by facing your difficulties, what I've said to you about resampling dialogues, and also number of GCPs to choose. If you have any problems, if you're facing some difficulties in calculation, or you have any comments or suggestions for upcoming videos, just drop me a line. I will be glad to help you and be glad to serve you. Thank you very much for watching. Goodbye.